I finished replacing all the electrolytics and paper caps on this board, and now I'm going through and checking the resistors. And what I'm finding is that a lot of them measure way off value, but not because they're necessarily bad, it's because they're in circuit with other components that are affecting the reading. When you work with tube equipment and it's turned off, the tube elements are all super high impedance, basically an infinite resistance, so quite often you can check resistors in circuit with no problem, but it seems that when you've got semiconductors, that is not the case. So what I'm actually ending up doing is, if I read a value that's way off, I'm just replacing the resistor, because by the time you unsolder and pull up one leg to check the value, I figure I might as well just have clipped it out and replaced it anyways. So I've got a few more to check in this area, and that is done. While I've got this board out of the way, I also went ahead and replaced one of the large power supply filter capacitors. Now when I first opened up this set and took a look at it, I suspected it was a replacement. It didn't fit in there that well, and it looked a little sloppy. Well, when I undid the leads for this, indeed, I found that there were clipped off leads underneath. So I'm really sure now that this is not an original. This is a replacement. And check it out. It's already gone bad. So the original went bad, was replaced with this, and this has gone bad. So I for sure am replacing it. So there's a nice little new replacement, and there's another one buried deep down in there that also needs to be replaced. I'll get at that when I work on this board, which I will start doing shortly. I've moved on to the sweep board now. It has a horizontal and vertical oscillators and horizontal outputs. Same procedure as the other board, replacing the old capacitors, electrolytics, bipolar electrolytics, and paper caps with new, and replacing the out-of-spec resistors. I think this takes the prize as the most extreme. Example of component size reduction. 5 microfarad, 10 volt non-polarized, and the ceramic equivalent. I just finished up with this board, replaced all the caps and quite a few of the resistors, and replaced the second power supply filter cap, and there's a big bumblebee back in here as well, got that replaced, which just leaves one thing, the vertical board. It's going to be kind of tricky to get out because it is soldered on, I think, with at least 3 stakes. You can see them coming down here. There's 1, 2, 3. Those go right through the board and are soldered in. Perhaps I can heat them up from this side. Like I can see some solder oozing out there. Not so much on this one. And then there's this guy. That one maybe I could even get from this side. But one way or another, I want to get it out of there. And once I do, get that recapped, it'll be time to reassemble this and try a power up. Just as I had hoped, I was able to heat these tabs up from the top side. And I think the board is ready to come out now. I'm going to be careful because there's a fine wire, several coming off from this board. I think those are the outputs going to the yoke. It's hung up because there's one little pocket over here. Hooks over the board. Get out of the way. Here output transistor. Looks like it's socketed. No heatsink though. Guess the body of it must be enough to dissipate the heat. A vertical output transformer, I presume. And here's what I want to replace, those 4 capacitors. Here's another example of the extreme size difference between the old original 7 microfarad 10 volts non-polarized and the new ceramic 6.8 microfarad at 10 volts. Alright, final board has been recapped. Time to reassemble it and try to fire it back up. It's all back together, so I guess there's nothing left to do but plug it in. Give it a try. Here we go. Static out of the speaker. Excellent sign. And we've got a raster. Alright, I guess I didn't screw things up. But did we get any reception? Turn the volume down so YouTube doesn't complain. Okay, that's gain. I'm not sure which controls on which. Okay, I think this is a vertical hold. No, it's probably horizontal hold. And it's brightness, I think. Vertical hold. So I'm having trouble syncing. The tuner's a bit dirty. There's a gain switch, 3 positions. I got it in the highest gain right now. I believe this is contrast. That's volume. It's weird because it almost locks at one extreme of the horizontal, or sorry, the vertical hold. Kind of around the middle of its travel. Kind of locks. And it starts rolling again. So I wonder if right around here it's actually, I think, running at twice the vertical frequency. Because this looks just about right. But I can't lock in. Now there are a bunch of trimmers on this thing. You may very well need to adjust those. That's horizontal. Horizontal seems to lock in just fine. Not the vertical. So I'm going to look on the service info and find out which trimmers are for what. See if I can tweak that. Actually, I could probably take a pretty good guess. There's only 2 controls on the vertical board. Adjusting one of them now. I think it's, actually, now that I think about it, it's probably height and linearity. Both be linearity. Service info here, they have aux vertical linearity and vertical linearity, R8A and B. Back ways. Okay, there's height and there's a vertical hold and there's also a vertical aux hold. That's the one I'm curious about adjusting. So on this board. I'm going to guesstimate. I'm going to guess it's this control. So it just made a big difference. Alright. I'm going to put the vertical hold on like the center of its travel. And adjust an internal control so it locks. Alright. Now the external control again. Alright. We got a little bit too much height. Otherwise, it's looking pretty good. Now, this is a pretty weak signal I'm feeding in right now. So I'm not expecting it to be fantastic. Now I got touch the case and reception gets kind of funky. Alright, so height. That must be height. Yeah. There's something right around there. And I'm going to feed a stronger signal in, see if we get better reception. I've been using kind of a half-ass setup to feed a signal into this set, taking an F connector, some alligator clips, and do an audio type RCA plug into the antenna jack. Well, I ran over to Radio Shack, which is going out of business and selling stuff off dirt cheap, and got some adapters. I was hoping to get a single RCA male to F female, but I had to use two separate adapters. It cost me all of about $1. And maybe it would have been nice if they were both gold plated, but it should do the job just fine. So now I can feed this connector directly into this end and then plug this directly into the set, and I'm hoping I will get a sharper picture. Yeah, that is a much better setup. Now let's see what kind of difference it actually makes. Yeah, I think that looks better. This is the gain 3-position switch. I think in the middle looks pretty good. Contrast control. Brightness.
Depressed. 110%. This is it? Non-functioning? The end of life's highway.
Yeah, that looks pretty darn good right there.
Well, what can I do? I'll arrange a discharge.
I would say this is a successful restoration. Now what's left is to get a test pattern on there, some for the vertical linearities off a bit. I'll clean up this optical assembly. And just put it all back together. I have this set hooked up to a test pattern generator now, and I've been adjusting the linearity and the centering. Got it centered pretty easily by going down through this hole in the front of the chassis and adjusting a magnetic centering ring. All you have to do is get your finger down in there and slide it around, and you can move the picture around. So right about there looks pretty good. And there really is no adjustment for the horizontal linearity. It's a little bit wider on the far left, but not too bad. Now, the vertical linearity is another story. There are two adjustments on that vertical board. Vertical linearity auxiliary and vertical linearity. Also indicated here. Now I've adjusted two of them, and this is the best I could get. Demonstrate what effect those controls have. And you can also adjust the height. So no matter what I've tried, it's more stretched out in the center than at either the top or the bottom. Now perhaps that's just as good as these sets can get, or could be a problem with some of the components. Well, I have my other Philco Safari that's unrestored, so I'm going to get that up on the workbench and compare the two. Here's my other unrestored Philco Safari. I don't want to pull the chassis out just to inject a signal, so I have it clipped to the antenna. We'll see how that works out. So reset to channel 3, I do believe, so let's see what we get. Super noisy. Let's see, I'll try boosting the output level on my RF modulator. Not making a whole lot of difference. Try the fine tuning. A little better. Anyways, right away I can see a few things. Linearity does look better. Squares are a little bit taller at the top than at the bottom, but it's now bulging out in the middle like on the other set. And I can also see that this has some horizontal issues as well. Adjusting some of the controls here. So overall the whole thing is tilted at a bit of an angle. I like that. And there's a little bit of twisting as well. Some range control. I'll just leave that in the middle. It's volume. Let's see, this is horizontal hold. That doesn't really affect the twisting at all. Brightness. And vertical hold. Vertical hold on this one's pretty touchy. It's got to be all the way at the extreme, and even then it's a little twitchy. So that is curious. That is curious. The vertical linearity seems to be better on this set. And I for sure did use, I think, 3 of the ceramic caps in the vertical circuit. So there are a number of non-polarized. We got 7 mic right there, a 5, another 5, and those are part of the linearity control. Too bad that board is kind of a pain in the ass to get out, but it's just a small board in those caps. Once I get the board out, the caps are easy to get at. So I think what I'm going to try doing is get that board back out and swap out those ceramics for some bipolar electrolytics and see if it makes any difference. Alright, here it is with those 3 bipolar ceramics replaced with bipolar electrolytics. I'll reinstall it and try that test pattern again. Wow, check that out. I have not touched any of the controls and it looks dramatically different just by replacing those caps with electrolytic types. So, let's see. This is the what they call the vertical linearity aux control. And here's a vertical linearity control. Yeah, wow. Can make a much bigger difference with it now. It says 3 controls. They all kind of interact. You got height. And the 2 linearity controls. Of course, what I'm trying to do is get the height of all the squares to be the same. Thing's kind of egg-shaped right now. Alright, well, I'll keep fooling around with this, but I can already tell that ceramics are probably not the best choice for this particular application. But there, it's actually looking pretty good. Alright, I think I got the vertical linearity pretty good. Horizontal's off a little bit. Now, everything I might be bummed out about the time and the few bucks I wasted on the ceramic caps. No, not at all. In fact, this is one of the things I most enjoy about the hobby, is experimenting with new components and trying to get these sets to work good again. So yeah, that's just another little tidbit of info I can tuck away, is that best to use electrolytics rather than those MLCC ceramic caps when replacing bipolar capacitors. I think I might go ahead and do the same on the horizontal. If there are any bipolar in the horizontal, maybe clear that up a little bit, or maybe I'll just have to live with it. I mean, it's pretty darn good as it is. It's really just a little bit on the furthest left edge there. That's a little bit too large. I went back and replaced a handful of ceramic caps I had installed on either of the larger boards with bipolar electrolytics, and it really didn't make any difference. Horizontal linearity still off a little bit, and there's a little bit of horizontal twisting. So I guess from that I can conclude that ceramics are okay to use on those boards, but not on the vertical output circuit.